So 7-1 is, we are going to be working with simplifying our radical expressions. All right. So what's going to happen is, like example 1, we are going to be giving a square root of like 243. And what we have to do is we have to think about what perfect square it goes into 243. Before we find our number, we're going to think about some perfect squares. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared, 16. 5 squared, 25. Class, 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. And last one, 10 squared, 100. Those are perfect squares. Means that if you took the square root of 1 is 1, square root of 2, or square root of 4 is 2, square root of 9 is 3. It's called a perfect square root in perfect squares. We need to know what number, which one of these, the biggest one of these, goes into 243. If you don't know, you literally, with your calculator, you can go 243 divided by 100. Hopefully you guys know that that doesn't go 81. And we have 3. If it wouldn't have, I would have went to 64 and so forth down until I get the biggest perfect that goes into it. So 81 times 3. So 81 times 3 is still 243. So I'm rewriting that. So if you see the answer at that point, you can jump to it. If not, break it down. So we have the square root of 81 times the square root of 3. Time out. Did you get how I got 81 and 3? Okay. Right. So then all you're doing is you take the square root of this and you break it to the square root of 3, because you can, because it's still 81 times 3. When you have the square roots, you'd multiply the number underneath. So it's still the same thing. So now, what's the square root of 81? 9. Square root of 3.
Yeah, I was just confused. I thought the perfect square root was the number had to be the same, multiplying by the number.
Yep, so 9 times 9 is 81. This is my perfect. 81 is perfect.
Okay.
Yep, 81 is the perfect.
Also, you can change that.
You have to change the number so you have a perfect and another number. That's why we chose 81. Okay? Sometimes you start with the square root of 10 times the square root of 5. So sometimes we start with this. When you start with two things, the first thing you want to do is multiply what's underneath it, right? So we have the square root of 10 times the square root of 5 gives me the square root of 50. I want you guys to think for a moment. Don't tell me the answer, but I want you to think about what's my perfect, my biggest perfect that goes into 50, and what number is it multiplied by? Don't yell it out yet. If you don't know, find where 50 would go. 50 would go right here, and look, does 49 go in it evenly? Does 36 go in it evenly? Does 25 go into it evenly? So, what's my two numbers? Class? Lincoln, you know what it is?
I'm sorry, what was the question?
What's my two numbers? Josh, you know what it is? 25 and 2. So, 25 and 2 is my 50. Again, at this point, if you know the answer, you could put it, but if you don't, we'll break it up. So we have the square root of 25 times the square root of 2. So, square root of 25 is 5, square root of 2. Alright, so if you have the square root of 18, the first thing you're doing is you're finding two numbers, one being perfect. Right? So, what two numbers gave me 18? 9 and 2. So we have the square root of 9 times the square root of 2. Square root of 9 is 3, leaving the square root of 2. On number 7, just what's the square root of 9? 3. And then you just bring that down.
Okay. So these are pretty short problems.
Yep. When you have a number out in front, all that means is you're going to multiply it by whatever you get here. So we have the square root of 80. So what numbers can we break 80 up into? So we had one. Remember, 10 and 8, neither one is a perfect. So it has to they have to be perfect. 4 and 20, but so you could do 4 and 20, but does 4 go into 20? Yeah. So that means you're going to do it twice. So actually, if you could do it twice, or you could know that means that 16 goes into 80. So if you didn't know that, I can go back. If you want me to do 4 and 20, how many of you did 4 and 20? Because I can do 4 and 20, but then what happened is you have to break down 20 again. So you have 3 and 80 is 16 times my 5. So I have 3 times, what's the square root of 16? 4. And then we're timesing by the square root of 5. So my final answer, 3 times 4 is 12. Square roots of 5.
So bizarre.
We are doing the front side and odds on the back.
Wait, when you put it back?
Word.
We are doing the front side and odds on the back. Tony, if you complain one more time, you can do the whole thing, front and back.
Jeez. I can't do anything.
I like it, Richie. I like it.
Don't be lazy. Get up and get it. All right. One more before we move on. One more before we move on. Number 9. So number 9. So you have square root of 20 times the square root of 2. Number 9. Did you get it, Tony?
Yeah.
Okay.
10 and 2 for 20. Right.
Remember, has to be a perfect.
Well, wait, but that's not what we're doing for 2.
Yes, we did. Which, on number 2, 9 is my perfect.
But
Square root
20,
of 20.
there's no perfect square root of 20.
You have to look at 2 numbers. One of them has to be perfect.
Oh.
9 and 2, 9 is a perfect. But you can do it 2 ways. You can look at it, you're breaking it up, which is fine, because it does have a number.
4 and 5.
That's right.
Because 4 is a perfect. Okay.
That's right.
4 and 5 are what you did for 2.
You're
You're going to just bring it down.
So you're saying, like, there could be multiple different answers, obviously, to get to 20, but you have to pick the right one.
You have to pick the one of them that has the perfect. Yep. Yep. So you can break it up like this first, because that's how the front row wants to do it, which is fine. Or you could have multiplied the 20 times 2 and then broke that down. You're going to get the same answer. Square root of 4 is 2. And then we have square root of 5 times the square root of 2 is square root of 10.
Yeah.
we have to make sure that there's no perfects in 10. Look back here.
But there is, but there's not.
9 doesn't go into it evenly. 4 doesn't go into it evenly. So we're done. But 1 doesn't. 1 won't help us. 1 won't reduce it. All right. Here we go. All right. Example 3. Square roots of 2 over 5 square roots of 3. There is a rule that you have to remember. You cannot have the square root on the bottom. So we have to get rid of the square root. So we have to multiply the top and bottom by the square root that's on the bottom. So what are we going to square? Square root of 3 is right. So we're going to multiply top and bottom by the square root of 3.
Yeah, you were.
Square root of 2 times the square root of 3 is square root of 6. And we have 5. Square root of 3 times the square root of 3 is? But what is the square root? What is the square root of 9? 3. So it is going to be 15 on the bottom. So we have the square root of 6 over 15. Is there any perfects in 6? Remember, the first perfects are 1, 4, 9. So there's no perfects in that, so that's our answer. I will tell you that I'm going to be jumping from square root of 3 times the square root of 3 to 3. Anytime you have two numbers that are the same multiplied together, it's going to give you that 3. You can always put that square root in there. All right? All right. We'll do 7 over the square root of 2. So, yep, square root of 2. All right, what's my first step, class?
To get rid of the...
Yep, so we're going to multiply both by the square root of 2 is right. Top, you have. Bottom, we have 2. If you need to, say square root of 2 times square root of 2 is square root of 4. And then take the square root is 2, that's fine. Now, if I would have had this as an 8, if it wouldn't have been a 7, but it would have been an 8, then you could have reduced that. But if pretend this was an 8, 2 goes into 8 how many times?
4.
Yep. So that would have been 4 square roots of 2. Yep, so you always have to look at the numbers to make sure you can't reduce. Okay? All right, last concept. If you don't get this concept today, don't fret, but I am going to show it today, and then we'll see what happens. So example, don't fret. Example 5.
What does fret mean?
Don't worry. Don't worry. All right. Square root of 3x minus 5, and we have it squared. All right. Can anybody tell me why, let's think about this before I tell you what the answer is. Can anybody tell me why the square root of 4 is 2?
Because 2 times 2 is 4.
Because 2 times 2 is 4. Because underneath this, you would have 2 squared is, so this cancels with that. So, what Over here, what you would do is you cancel this square right there, and my answer is 3x minus 5. Again, remember we had the square root of 3x minus 5 squared. So this square and that square root cancel. All right? So the answer is 3x minus 5. What happens? Right, well, you got rid of your square and your square root. Yeah, I mean, you could keep parentheses there, but you don't need them, right? What's going to happen is it's going to be a little bit more challenging than that on some of them if you had, and this is the one not to fret about because this is really challenging. Don't fret. When you see something like this, x squared minus 14x plus 49, hopefully, since we did the whole last chapter with something, what would you are going to factor it. Since we're doing square roots, I will tell you that underneath your square root is going to be perfects. So, you take the square root of the first, which is x. Same sign, negative. Square root of the last is 7. Now you can cancel this, can't we? This and that goes. X minus 7 is our answer.
What happens to 49?
Because remember, this right here, x minus 7 squared. How do I multiply this out?
Oh, just kidding.
This minus
Gotcha.
twice, and you'd FOIL it.
Yeah, I got you.
But to get here, just so you know, you take the square root of this, square root of that, and it's the same sign. But when you to FOIL this out, you'll get that back. Okay? Now, if you don't get this, this is the one not to fret. We'll have a while to work with it. All right? Do not fret. All right. Do not fret.